Birds of a feather flock together, meaning that people coming from similar background, character, or taste tend to represent one another. This is a phrase, and today I will be talking about an algorithm which exactly represents this phrase. That is kNN algorithm. K, nearest neighbor algorithm, states that similar things exist in close proximity, where k is the number of data sets which are considered for the classification. K is a positive integer and it ranges from 1 to n. The kNN algorithm gives us an understanding to calculate the distance between 2 points. kNN is used in both classification and regression. This is Euclidean's formula to calculate distance, and kNN can be recognized from this algorithm as well. In order to get the correct value of k, one should run the kNN algorithm several times by taking divergent value of k. The value of k which gives the minimal error is the value of k which needs to be selected. The most preferred value of k is 5. Often it's noted that a large value of k is associated with a much complex model, which is a fallacy. A small value of k, for example, taking k is equals to 1 or 2, has low bias and gives high variance, which is associated with more complex models, whereas large k value has high bias and low variance, which is associated with simpler models. The difficulties incurred while training machine learning models due to the presence of high-dimensional data is known as the curse of dimensionality. As we can see in the diagram, as dimensionality grows, there are fewer observations per region. In dimension 1, data is relatively packed, but as we move forward, we see that adding a dimension sprawl the points across the dimension. The curse of dimensionality is especially a problem for kNN because this algorithm requires point to be close in every dimension. And with every dimension being added, it makes it further tough for 2 points to be close to each other. So now the question is, how do we challenge this problem in kNN? One of the possible solutions is adding more data to the data set. This adds more density to the data space, which brings points closer. The advantages of kNN are that it's effective when we have large training data. It's robust and easy to implement. It can be used for both classification and regression.
It is useful for non-linear data and it provides high accuracy.
The disadvantages of kNN are that it's computationally expensive because of its ability to store all the training data. When the value of n is big, it becomes slow. It is sensitive to noisy and missing data. It does not work well with high dimensionality, as this will complicate the distance calculating process to calculate distance for each dimension.
kNN is a versatile algorithm and has diverse applications in real life. It can be used in the banking system to detect whether one is fit for loan approval or not, if he or she has similar traits to a defaulter. Now, everyone must have heard about Netflix. Netflix uses this algorithm to give its users best recommendations. kNN is one of the fundamental algorithms of machine learning, but it still has enough room for improvement and modifications. Thank you.